All right, so we're going to talk today about nonlinearity. And I'm going to introduce 4 inconvenient truths for carbon measurement and carbon calculation that also show why healthcare has it worse than every other industry in our economy. Firstly, let's remember what carbon dioxide does. CO2 in the global economy looks like this. And obviously we talk a lot about some of the big carbon sources, things like energy, transportation, agriculture, waste management, etc. Transportation is another big one. But remember that these items actually don't exist in isolation. They exist to help us do stuff. And one of the things that's often forgotten is the fact that there's a hierarchy to emissions. Transportation, for example, doesn't happen by itself. It happens because we need to go somewhere, or we need to get something, or we need to do something. And when you start breaking down this rather large 16.2% portion of transportation, which you can see here in the pie chart, you start to realize that actually a lot of the surface or road transportation that makes up a very large proportion of the carbon footprint of any one nation, or any one developed nation to be clear, is actually made up of things we can change by changing other things. In particular, think about commuting. The vast majority of people travel in rush hour by car or by any other transport means to get somewhere, to do a particular job. So if people started working from home more, that radically reduces the amount of cars on the road. And we saw that during the lockdown periods in the 2020 and 21 pandemic. Because people stopped driving around, cities were a lot quieter, and the air was actually cleaner. This also a lot of places also see wildlife return. Sheep would often walk into the middle of a village. And some species of wolves and even dolphins were seen in different parts of the world where they had long vacated. So this hierarchy tells us that there's more to this than measuring individual variables here, because there are dependencies between them, which then create dependent variables in the overall carbon calculation. And unfortunately, every calculator doesn't cover that. I'll return to that in a minute, but just to solidify the point, this can mean that healthcare is the sink for the effects of all the other industries in the economy. Healthcare suffers from the fact that all the emissions don't impact the economic sectors that created them. They create demand in healthcare. And what's worse is healthcare has nowhere else for its emissions to go apart from healthcare itself. And that's a crucial point here, because that creates a cyclical dependency, because it connects the downstream and upstream of the patient emissions together, right? So the upstream impacts are things from extraction, containment, transportation, cracking of plastics, the freight, logistics, and manufacturing of products, and even their storage in hospital grounds and facilities. They're then used on patients and then disposed of, which then goes through a transportation to potentially incineration for energy source. And that latter half alone releases 45% of the weight of the waste in carbon dioxide. Never mind the particulates that also go with it if it's unfiltered. And in total, this is embodied carbon. This is the stuff that goes into the production of an item or a care product, which you cannot actually see just by looking at the product. You can't feel it. You feel the results of it, but you can't actually feel it. And this can mean the first inconvenient truth, which is that embodied carbon isn't necessarily intangible. It's almost invisible. You can only know of it through its interaction with other things. A bit like a black hole. So when they first discovered a black hole, they discovered it through its effect on other bodies. The black hole itself is as good as invisible to them, certainly by light. Now, while showing my age, kudos to anybody who remembers this film, the first thing you have to realize is that As well as being intangible, there are different things that are responsible for the carbon in each stream. Consider a life cycle analysis. You have multiple steps within them, and each of those steps can differ depending on the context. And that can mean that other calculators are totally unsuitable for the use rather in healthcare. Let's take some of the three probably most common ones. Carbon data and carbon cloud, which are often used to quantify items in retail, are incomplete. They cover extraction processing all the way through to the supermarket shelves. But they don't go any further than that. They don't measure the disposal effect. And of course, they don't measure how much energy is required to keep it cool in a home domestic freezer, for example. Each of those are relevant to the carbon footprint, but they don't measure it. So that means that the data, whilst it's okay for what it is incomplete. Not only that, by disconnecting disposal, you can never get a circular measure out of it. That means you cannot trace anything that comes back into the system using something like carbon data or carbon cloud. In the case of Mackay looks at things from a macroeconomic perspective, a macro level. That means it looks at the UK sector as a whole, or UK economy, as a whole, as if it's one sector. The problem with that, of course, is that within the economy, there are several sectors. And if you're looking at lower level, higher resolution, if you like, elements, you need more fidelity than can be provided by this model. Not only that, some of the decisions made by Mackay and Bayes by proxy are simply wrong. Right? Carbon dioxide capturing technology. For those who aren't aware of what that is, that's basically a technology that is currently used, or currently available, but it's typically attached to the outflow vents in a factory. In essence, capturing the carbon dioxide and storing it, or also embedding it within concrete. In essence, allowing the concrete to last longer than it otherwise would do. The trouble is, that's okay when it's attached to the actual exhaust pipe, if you like. As soon as you have to try and capture this when it's in the middle of nowhere, then you have problems. Even when it's attached to the exhaust pipe, you're effectively emitting about 40% more carbon dioxide than you're actually saving or filtering because of the upstream effects, in particular how it gets its energy and how the factory works. Because the factory doesn't power this. Effectively, other electricity powers it generated from downstream power sources, energy sources. So yes, sure, it can be improved if it uses renewables, but actually in its own right, it doesn't reduce the amount of energy, it actually increases it. It increases about 80% and emits about 40% extra carbon dioxide, which has to be renewable, otherwise that process is actually less beneficial. In fact, it's worse for the climate overall. But when you stick it out in the middle of nowhere to try and filter it out of thin air, that's a fundamentally different challenge. It's a different scale. The amount of energy required to run enough fans to be able to suck up enough air to then filter the carbon dioxide out of it is immense. Where this has been trialed, it's still not net zero, but it requires the power of a volcano. Some of the most effective current technologies for this are located in places like Iceland, where they can take advantage of geothermal heat to turn turbines that are enough to power this thing. Not only that, the process is naturally suboptimal. You can only capture air in a particular locality. Once it's out into the atmosphere, especially in the upper atmosphere, there's no way you're catching it with this stuff. You have to hope that you're catching it at ground level before it turns into atmospheric carbon. And this is often much harder than people make it out to be. Yet for various reasons, including innovation funding evaluation problems, this technology has been given the green light, despite the fact that it is emitting much more carbon dioxide than it could ever take out of the atmosphere in the time we have left. Finally, probably one of the most famous and certainly longest lasting carbon calculators, the Carbon Trust. They have been and are a fantastic resource when you're talking about energy, but their understanding of how small businesses run, or even households more generally, is actually lacking, dare I say. The focus on energy misses all the other emissions associated with transportation, commuting, and supply chain. So they have a small business calculator, so anybody who wants to go along and check it out, feel free. But you'll notice that they are missing a number of processes that all emit carbon dioxide. So that needs improving. All of these, every single one of them, even the best ones, crucially miss nonlinearity. And that's our second inconvenient truth. Because healthcare creates demand on itself, it creates a magnified effect as it goes through the process. Not only that, healthcare has, especially acute care, has specific processes involved in it that actively increase the amount of carbon dioxide being generated, even for exactly the same stuff. And this can mean traditional face mask, which weighs 5 grams, processed in the community, has a carbon footprint of 52 grams of CO2. In acute care, that same mask can be as much as 1.7 kilograms of CO2, a radical increase in carbon dioxide emissions. And that conveniently leads us to our next inconvenient truth, which is that context is everything. It's not enough to look at other sectors and apply the thinking that's applied in those other sectors, mainly because of the fact that there are these cyclical effects within healthcare that have to be accounted for as well. If you don't, then you miss magnifications that happen within the healthcare context, such as the mask that we showed a second ago. And this has a knock-on effect on healthcare demand, of course. If we take a look at asthma. So on the left here, you can see the frequency of asthma per 10,000 people since the 1950s. And you can see that as we've increased our consumerism into the 1980s, we've also seen an exponential increase in asthma cases. More consumerism, more road journeys, more asthma. And also inhaler use. But inhalers themselves are not carbon neutral. A single inhaler has a carbon footprint of about 10 kilograms when it weighs mere grams by comparison. Actually, a lot of what healthcare does in its supply chain is trying to fill a hole by digging another hole next to it and filling the first one. That means you're always filling a hole. You're always filling a hole. So you have to fundamentally think about the problem differently. Because respiratory treatment is one of the biggest drains on the NHS. Its total cost is something in the region of £11 billion a year, of which the total economy contributes about £4.9 billion to that cost. 345 million of it from the NHS itself. And this happens because there are silos in procurement. So whilst procurement is 60% of the carbon footprint of the NHS, it also has the biggest potential for change. But this requires joining up different parts of the procurement and disposal scheme to understand where that actually goes, to almost visualize that nonlinearity. So if we were to take a walk through a purchase, a typical purchase will come from a category tower somewhere. That will then create a load of waste on top of the upstream carbon created through its procurement. That will then be translated or transferred rather to facilities to be incinerated for energy. And that releases carbon dioxide as well as some particulates in its transit. And this then creates demand on respiratory conditions, which in turn has to pull supply from other supply chains, which themselves, of course, have a carbon footprint. And that returns that carbon footprint back into the system. And what this does is create a cyclical demand, in this case from respiratory, on respiratory. But a lot of that is sourced downstream. So why is it such a big deal? Why are inhalers such a big deal? Well, inhalers actually contribute 3 to 4% of the entire NHS carbon footprint. And the reason why that happens is because of a decision that happened in the 1980s. Back then, there was a movement to remove CFCs, or chlorofluorocarbons, from any propellants used in any type of canister, whether that is hairspray, inhalers, or even fridges. CFCs were eating away at the ozone layer because they are ozone depleting. As a result, they were outlawed, they were banned. But the solution to that in the pharmaceutical industry was to introduce hydrofluoroalkanes, or HFAs. While they don't eat ozone, they are a greenhouse gas. 1 kilogram of HFAs is equivalent to 438 kilograms of CO2. That's more than nitrous oxide. 70% of inhalers are meter-dose inhalers, such as the one you can see on the right-hand side here. Even moving to the Swedish proportions, where the vast majority are dry powder, would save 2.1% of the NHS's entire carbon footprint just doing that. And that means that you are also cleaning up a significant amount of impact, or downstream impact from other category towers, for example. And that leads us to the next inconvenient truth, and that is the respiratory demand. Your respiratory colleagues are cleaning up your mess. If you don't effectively deal with the waste disposal, the person that pays for it is your respiratory consultant. And these are linked. And as I said earlier, even just moving to the Swedish model, just one single thing, sure, that would save 550,000 tons of CO2 every single year, but also that only covers this bit. That only covers this bit. So whilst it's great that people are now thinking about working together, this is only 2% of the entire NHS carbon footprint. When it comes back through the system, will serve this portion, this latter half on the right-hand side. But what about the rest of it? The demand created by any one of these category towers at the point at which it buys creates demand elsewhere in the system, which comes back into the system. So one of the most effective ways of reducing demand is to think about climate at procurement in the effect it actually has. To simplify it down to a tiny, tiny proportion of a social good number somewhere else is not an effective way to deal with this nonlinear effect. Because the social good number will change, because context is everything. Embodied carbon is a black hole. You have to measure it by the effect it has on something else. Carbon calculators, traditional ones in other sectors, are not sufficient because they miss nonlinearity, the cyclical effects it has on health. Context is everything. And respiratory demand becomes your bucket to clean up the mess you leave. Don't leave your colleagues with a mess. So I'm going to leave you with that warning against friendly fire. Obviously, you can get in contact with us on the details on screen. Thanks very much.